After completion of this video, you'll be able to link CAD files into a Revit project, convert two-dimensional lines into three-dimensional walls, describe how two-dimensional files can be used in three-dimensional BIM workflows, and explain how Revit's Wall tool converts two-dimensional lines into three-dimensional walls with embedded data. Start by opening Revit. On the home screen, click the Open Models button to open the dialog box. In the Open Revit Project dialog box, navigate to the folder containing the Revit project from the provided dataset. Within the project browser and in the floor plan views, double-click on the view you want to access. For this example, double-click on the base floor level floor plan view. It should now be bold, indicating this is the current view, and looking down from above, you can see the north, south, east and west elevation markers. On the ribbon, on the Insert tab, on the Link panel, click Link CAD. In the Link CAD Formats dialog box, navigate to your desired folder for this example. That should be the folder containing the provided dataset, and click once on the base level drawing file. Linking a DWG file into Revit establishes a dynamic connection similar to an external reference in AutoCAD, which keeps the file updated with external changes, unlike importing, which creates a static copy within the Revit model. Linking is good practice, as importing a static copy could be out of date. For example, walls may have been moved in the original file and they wouldn't update in this Revit project. On the other hand, if you link a file, it remains up to date if changes are made in the original. Before linking, check the layer and positioning settings to ensure proper alignment with your Revit project. Keep the colours, layers and import unit settings as default, however change the positioning so it is auto centre to centre, and ensure it will be placed on the correct level, such as the ground floor level in this project. Click Open to link the file into this Revit project. Once linked, the 2D plan appears in your workspace as a static drawing, and while useful, it lacks the intelligence and interactivity flexibility of a 3D model. Convert these lines into parametric 3D walls by going to the ribbon. On the Architecture tab on the Build panel, click the Wall tool. The ribbon changes to reflect the tools available while creating or modifying walls. In the Properties palette, click the Type editor to select the exterior wall type. And in the ribbon, set the wall properties as desired, such as the height of the wall to the next level, which in this example is the upper floor level. Click Location Line and select Finish Face Exterior. The 2D line that you click will be used to position the exterior face of the wall. On the ribbon, in the Draw panel, click the Pick Lines option. Hover your mouse over the line indicating the exterior of the wall. Revit displays a dashed reference line indicating which side it will create the wall. Once this dashed line is on the correct side of the 2D line, click your left mouse button to convert the 2D line into a 3D wall element. Press the Escape button on your keyboard twice to end the command. In Plan View, these lines look very similar to the AutoCAD lines. Let's look at the project in 3D. Move your mouse to the ribbon. On the shortcut menu bar, click on the default 3D View button. It looks like a little house. On the View cube, click on the top corner between south and west to view the project from this angle. Place your cursor on the View cube and holding in your left mouse button, drag the View cube, spinning it to spin your project model in the same direction. And place your cursor over the edge of the 3D wall you created. It should highlight blue. When it does, click your mouse to select the wall. Notice how the Properties palette displays the properties such as base and top constraint, area, volume and length of the wall. Revit's parametric features ensure that changes to one element will update across all views. So let's adjust the wall's height and watch it reflect in the 3D and elevation views. In the project browser, in the elevation views, activate the south elevation view by double-clicking the view name. Again, select the wall by clicking on it. Grips appear as triangular symbols that allow you to drag the wall's base, top or sides, changing its length and height. Drag the triangle grip at the top of the wall to edit its height, snapping to the next level up, the roof level. Then click on the 3D View tab at the top of your screen to return to the 3D view. And notice how it changed height in this view automatically. The change affects all views parametrically, which is an advantage of working with a 3D model. Unlike the AutoCAD drawing, where the user must manually update or draw new elevations, in Revit the element is updated automatically as any changes take place. To reset the height in the Properties palette, ensure the upper floor level as the top constraint and click the top offset area and type 0 to set it to a 0 offset and click Apply to return it to the original height. This locks the top of the wall to the upper floor level. While the AutoCAD lines have gaps for doors and windows, in Revit the 3D wall should span the entire length of the external wall. And note how when converting lines in Revit only reads the length of the line segment as drawn. Return to the base level floor plan view by double-clicking the level name in the project browser and click on the wall once to select it. Dynamic grips appear, this time represented by small circles at the end of the wall, and they can be dragged to correct the wall length in plan view. Using the wheel on your mouse, roll the wheel backwards to zoom out from the view. Clicking and holding in the wheel while moving the mouse pans the view. You can pan left or right. You can use both of these to good effect so that you can see the entire wall length in one view. When you do, place your cursor on the small grip and drag it to edit the length of the wall. When your cursor is over the end corner, you'll notice a small magenta square symbol indicating the endpoint snap. Let go of the grip at this point to snap the wall length to the end of the 2D line. Doors and windows in Revit are more than just placeholders. They're intelligent components packed with data. Let's add a door to see how it interacts with the walls. Return to the 3D view by clicking the 3D View tab at the top of your screen. To activate the Orbit command, click and hold the mouse wheel while at the same time click and hold Shift on your keyboard. Move your mouse to orbit the model in 3D and look around the newly created wall. Return to the base level plan view by selecting the view name in the tab at the top of your screen. On the ribbon in the Architecture tab, on the Build panel, click Door. And in the Properties palette, notice the different types of door loaded into the model. More are available from the library if needed, and they're completely customizable, so you can create exactly the type of door that you need. From the type selector, select the door's external single flush type. Move your cursor over the wall, and notice when your cursor is near the interior or exterior face of the wall, it changes the opening direction for the door. When you have it opening in the correct direction, use the spacebar to flip the swing of the door as needed. And once correctly positioned, click your left mouse button to place the door. Press Escape twice to end the door command. Notice when it is placed in a wall in a plan view, the door cuts the wall so it appears as it did in the AutoCAD floor plan drawing, adhering to traditional drawing practices and standards. However, when you activate the 3D view, notice that the wall is not split as it was in the 2D AutoCAD file. Each component includes valuable data such as material type and dimensions. This makes project coordination more accurate and efficient. Activate the south elevation. Again, the view automatically updates to display the addition of a door. On the ribbon, on the View tab, Windows panel, select Tile Views to display the 3D, floor plan and east elevations at the same time. In each view, you may need to zoom out and pan using the mouse wheel so as to better position the model elements within the view. In the plan view, zoom into the door and click on it to select it. Place your cursor on top of the door and click and hold your mouse button and drag the door along the wall to relocate it. Notice how all three views update at the same time. In the project browser, expand Schedules. Double-click the door schedule to see how adding doors automatically updates quantities, costs, and other information. In the elevation view, click on the door to select it, and in the Properties palette, click the Edit Type button to open the Type Properties dialog. Scroll down to the Identity Data section and Manufacturer, and here click and enter Solid Door Company into this field. Click Apply and OK to return to the project view, and notice how the schedule contains the data entered automatically. On the ribbon, on the View tab, in the Windows panel, select Tab Views to return to one view.